Welcome to Royal Math Podcast. Today, Activity 17, Area of Composite Figures. In this podcast, you will get the formulas needed to find the area of geometric figures and learn how to make a composite figure out of an unknown shape. Now, a composite figure is made up of two or more geometric figures. Now, before we get to the composite figures, let's go ahead and look at the formulas that make up each individual shape. All right, so here we have the different formulas for triangle, parallelogram, trapezoid, and circle. And also we look into a little bit of semicircle and quarter circle. So looking at the triangle, we can see the triangle on the left has a base on the bottom. And then at a 40 or 90 degree angle coming from the base extending up to the highest point of the triangle is the height in the red dotted line. On the right, we have a right triangle who obviously has a right angle followed with a base and a height touching and coming together at that right angle. Below it in green, we have a parallelogram. Remember, a parallelogram is basically a rectangle that is leaning to the side. So we have either base could be used for the measurement, and then the height is the distance between the two bases at a 90 degree angle. Below that in blue, we have a trapezoid. Now, I have two examples of a trapezoid. Most people think that a trapezoid is only the blue figure on the left, with two slanted sides coming together towards the top base. But it can actually be only one slanted side towards the top base with a right angle for the other side. Now, we have two bases. Notice the formula for a trapezoid is area equals 1/2 times base 1 plus base 2. So because the base 1 and base 2 are in parentheses, we have to find out what those are first and add them together before we can multiply by the height and by 1/2. So remember, you have base 1 and base 2. On the right, you have base 1 and base 2. And notice the height is the distance between those two bases. Below, in green, we have a circle in green. Now the circle has a circumference, and then going through the circle, halfway is the radius. And so for that, we need to do radius squared, and remember, squaring a number means multiplying it by itself. So if this radius was 5, then the formula would be pi, which is 3.14, times 5 squared, and 5 squared is 5 times 5, which is 25. Now, a lot of times what they'll do is they will give you a line straight across. That is the diameter. To get the radius from the diameter, you simply divide the diameter by 2. Now, below, we have a semicircle, and a semicircle is an arc whose measure is half of a circle. The area of a semicircle is half of the area of a circle with the same radius. So if we were to write the formula for a semicircle, it would be area equals 1/2 times pi times r squared. And then for a quarter circle, you would have area equals 1/4 times pi times r squared. Now, for the semicircle, this flat half right here is the diameter. This measurement is the same as the diameter. So whatever that measurement is, you will simply take half of that to get the radius for the formula. For a quarter circle, the only thing that is shown is the radius. So whether it's this area or this line segment or this line segment, that is the length of your radius. Now that we know the formulas for the geometric shapes, let's go ahead and move on to a composite figure that we can solve for. All right, so here we have a problem that states a student dropped a piece of stained glass. A fragment has the shape shown below. Divide the fragment into smaller shapes that you can use to find its total area. So here we definitely have a shape that has no name, and with no name, it definitely has no formula. But we can divide it into shapes that we're familiar with. That way we can have a formula for each and every shape. So let's go ahead and divide this up. Starting on the right, I can see that there's a quarter circle. So I'm going to draw the line right there. Now next to it, if I look, I can draw a line right here, and now I have a long rectangle. And then once again, I can draw another line right there, and that divides the remaining shape into a trapezoid and into a triangle. Now, when looking for shapes to make from a large figure, what you do is the first place to look is wherever you have angles and lines coming together. So if you look on this shape, you can notice right here there was an angle, and so I drew it straight up. Over here another angle came together, and down here another angle, so thus my straight line to form the rectangle. And then last but not least, you can see the height or the width of this trapezoid. There's an angle, and therefore I was able to draw the line straight down to this other angle to form my trapezoid and my triangle. So now, first things first, let's go ahead and write out formulas for each and every shape. That way we know what measurements that we need. Starting off, we have a triangle. So I'm going to write area equals 1/2 base times height. Now notice I left a little space in between each letter. That way when I come back later and substitute in the actual numbers, I will have room and they will still lie underneath the corresponding formula variable. All right, let's go ahead and write the formula for the trapezoid. And that is area equals
Coach Johnson, please report
1/2.
to the office. Coach Johnson, please report to the office. Thank you.
Area equals 1/2 height times base 1 plus base 2. Third shape is going to be the rectangle. So area equals length times width. And the last shape is going to be the quarter circle. So that is area equals 1/4 times pi times r squared. All right, let's go ahead and begin. But like I said, first we need all of our measurements. So if we look at starting on the left with the triangle, here is our base. So if we count from the line, which starts right here, 1, 2, 3, 4, 5, 6, 7. So I'm going to write a 7 right there. That way I know exactly where that line measurement is. Next, I need to find the height. Remember, the height comes off of the base at a right angle towards the highest point. So I know it's going to go from here all the way up. So my height is going to be 1, 2, 3. So I am going to write this in. Let me do a dotted line to show the height. And we know that's going to be 3 and that it's coming off at a right angle. Next, let's move over to the trapezoid. We already have one of the bases measured for the trapezoid. So now let's measure the other base. The base starts here. So 1, 2, 3, 4, 5. So we know that this base has a measurement of 5. Now let's look at the height. The height is the distance between the two bases. So here's the first base, here's the second base, and the distance in between is 1, 2. So we know that the height is 2, and it obviously comes off at a right angle as well. Now that we have the measurements for the trapezoid, let's take a look at the figure to the right, which is the long rectangle. So it has a width of 1, 2. So I will write a 2 right there. Now let's look at its length. It starts here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know its length is going to be 10. Last but not least, let's go ahead and get the measurements for the quarter circle. And of course, the only thing that we do not know at this time is the radius. And remember, the radius can be measured from here to here or from here to here. So we'll go ahead and measure it. 1, 2, 3, 4. So we know that its measurement is 4. Now, I want to bring up a point here real fast for you guys before we get into filling in and substituting in the measurements. If we look at this the radius of this quarter circle, we can see that it's 1, 2, 3, 4, regardless of the direction that we go in. But if we go through right here, notice if we go diagonal across these square units, there's only 1, 2, 3. So that's an important thing to remember. When measuring with grid paper, you can measure left and right or up and down for your measurements. Now let's go ahead and solve for each formula. So first thing we're going to do now is we are going to write in or substitute the correct values for each variable in the formula. So beginning on the left side with the triangle, remember we have area equals 1/2 base times height. So we are going to write that again. We are going to write 1/2. And now we're going to fill in for the base. The base, remember, is 7. So times 7. And times the height, which is 3. All right, so now we work that out. And so we combine 7 times 3 is 21. So 1/2 times 21 is where we're at. And then half of 21, of course, is 10.5. And we know that this is units squared. All right, now let's move over to the trapezoid. So we know that the trapezoid is 1/2, and the height of the trapezoid is 2, so times 2, and then times base 1 and base 2. Base 1 is 7, plus base 2 is 5. So now we're going to combine 7 plus 5, and of course that is 12. So 12 times 2 times 1/2. And of course, 1/2 of 2 is 1 times 12, and 1 times 12 is 12. So we know we have 12 units squared. Now let's move over to the rectangle. Filling in and substituting the measurements, we have the length is 10 times the width is 2. 10 times 2 is 20, so we know we have 20 units squared. And then last but not least, we have the quarter circle. So we have 1/4 times 3.14 times the radius squared, which is 4, so 4 squared. We know that 4 squared is 16, so 16 times 3.14 times 1/4. Now, 1/4, when you multiply, or you can divide simply by 4. So remember, if you are multiplying by a fraction and the numerator is 1, whatever the denominator is, that's what you're going to divide by. So I'm going to go ahead and do 1/4 of 16. And when I do 1/4 of 16, of course, or 16 divided by 4, I get 4. So 4 times 3.14. And when I multiply that out, I get 12.56 units squared. Now, if we look down across my answers, it's pretty easy to tell what my answer is. Because if it says units squared, or if this was yards, yards squared, or inches, inches squared, you know that is your area. So now what we're going to do is we have to find the total area. So I know my total area equals 10.5 plus 12 plus 20 plus 12.56. And when I add all of those together, I get a total area of 55.06 units squared. All right, now let's move